Being a homemade chemist is fun. You can do a lot of things with simple material, but it is quite an expensive hobby. If you're not rich, getting or synthesizing the chemicals it's the most fun part. You can get chemical products from almost everywhere. For example, from pharmaceuticals like paracetamol or acetyl salicylic acid. Also from fertilizers, cosmetics like lactic acid, solvents like isopropyl alcohol, acetone, or ethanol, or even in supplements, for example, paraminobenzoic acid. But there is a group of chemicals that is not easy to get and yet very useful. Those are alkenes. A lot of reactions can be done on alkenes. For example, anti addition, Markovnikov addition, oxidation using potassium permanganate, epoxidation using metachloroperoxybenzoic acid, anti-Markovnikov hydrotation, and anti-Markovnikov addition, just for mention some. Okay. They are very useful, but how do we get them? The first strategy is to use synthesis, because there is a lot of ways to synthesize alkenes. The first is to dehydrate an alcohol using concentrated sulfuric acid or other acids. The problem with this synthesis is that alkenes with four or less carbons are gases at normal conditions. So I need an alcohol of five or more carbons, which I don't have. So this reaction is unsuitable by the moment. The second way is by elimination of a secondary or tertiary alkyl halide, which I also doesn't have right now, so this is also unsuitable. The third way is the Wittig reaction, but this reaction and others are out of my league, so basically synthesis isn't an option right now. The second strategy is to actually buy one, but this is how to say it is expensive and is boring, so this is not an option by the moment. The third strategy is extraction. It means getting the alkene from somewhere. And here is where the answer came. Terpenes. Terpenes is the answer. Terpenes are natural products that come from the acetate mevalonate pathway. In summary, acetate becomes mevalonate, and mevalonate becomes dimethyl allyl pyrophosphate, which is the initiator. There are a lot of different terpenes, but we are going to only focus on the 10 carbon terpenes, better known as monoterpenes. Between all the options, there are two terpenes that are monounsaturated and easily found on pine trees. Yes, I'm talking about alpha pinene and beta pinene, the main stars of this video. Unfortunately, there's an easy way to get pinenes, and it is by turpentine oil, which is a solvent that comes from pine resin. In this table, you can see the most present terpenes on turpentine, where alpha and beta pinene are the most abundant ones. For this experiment, the only thing you need is turpentine. This experiment is basically just a distillation, so add 150 milliliters of turpentine in an adequate round bottom flask. Then add the stir bar and the glycerin to the bath. I fixed the fractional distillation apparatus and it looked like this. I started heating. So, after a while, I added aluminum foil to isolate the system. After some minutes, the vapors started climbing along the column and eventually got into the condenser. The distillation started at 90 C, probably water or other volatile solvents. I got a lot of distillate before 140 C. Then the temperature stabilized at 143 C, which I believe is the alpha pinene fraction. The distillation occurred smoothly. After a while, the distillation stopped and the temperature dropped. I never get anything above 148 C, so theoretically, I didn't get beta pinene. I removed the column and fixed a simple distillation apparatus in order to get a higher temperature easily. I did this because I wanted so bad to get beta pinene, but even though the bath was above 200 C, I wasn't able to get anything above 150 degrees Celsius. I finally gave up and turned off the heat, finishing the distillation. I got this delicious smelling high boiling point oil. At the end, I got 81 milliliters of alpha pinene and these other fractions. I didn't get any beta pinene, and probably it's because the turpentine I got didn't contain beta pinene at all. I have some reactions running right now, so if you want to see them, please subscribe. Thank you for watching and see you in the next video.